Hello children, we have already discussed the acid part and the base part of this chapter, acid, base and salts. Since yesterday only, I think there has been a revision in your syllabus. Salt section of this chapter was the one which was the most difficult one and the most lengthy one, but thankfully now this salt section has been almost, I would call it as completely removed, except only for the definition of salt and the three kind of salts. Now you don't need to do any preparation of salts according to your new syllabus for 2021, because of the pandemic. Now the council has reduced your syllabus, and then one of the reduction, and exactly at that time only, if even one class if I was late, then I would have taught you the whole chapter, the total detail about acid, base and salt. If you remember in the beginning, in the first part of this chapter, I had said that that salt section is difficult, other sections are all simple and easy, and that very difficult side, like you are very lucky that that very difficult section of this chapter has been removed from your syllabus for 2021. So that's why I would say that you are lucky. Now then, since very small portion is there, so maybe our video will go very small today, because now only have to define about salts and then that completes your chapter. Yeah, I should tell you what we have done till now. So if I give a rough recapitulation of what we have done till now from this chapter. We started with acids, so we defined what are acids. Then don't forget that acids, when we dissolve in water, produces hydrogen ion as the only cation. Then we discuss about different classification of acids, about strong acid, weak acid in terms of the strength. Then we discuss about their origin, whether organic acid or inorganic acid. Then again we also discuss in terms of concentration, whether a dilute acid or a concentrated acid. Then also we discuss about the most important part, basicity of an acid. How many hydrogen ion it can produce, or how many hydrogen ion it will produce whenever it ionizes in water. That is what is the basicity of an acid. Then after that we discuss about properties of acid. Now that properties of acid as well as also property of base, as well as also a property of salt. In the property of salt, if you see in the last part of the syllabus, it says what is the action of acid on carbonate, that we already discussed it in properties of acid. Similarly sulfite, sulfide, all those we have discussed already as the property, and I discussed about main 5 properties of dilute acids. But in addition to that dilute acid, I also gave you 2 additional properties, then that's why it was the 6th and 7th properties I had discussed about chloride, and the other one was about nitrate properties. And don't forget that, again I'll mention that those 5 properties of acids very important. 5 different places in your book you'll come across that. Then we went to bases. We discussed what is base. Bases produces hydroxyl. They are actually metallic oxides and metallic hydroxide, including ammonium hydroxides. Then we discussed about soluble bases. Soluble bases are called alkalis. And we discussed also about strong alkalis and weak alkalis, something which can produce plenty of hydroxyl ion are strong, like sodium hydroxide and potassium hydroxide, whereas something which can produce very less amount of OH when they ionize or when they dissociate, that is what is weak. Like for example, calcium hydroxide, ammonium hydroxide produces less amount of less number of OH ions. Then we also discuss in terms of the acidity of a base. When you go to classification, means how many hydroxyl ion per one molecule of a base it can produce when dissolved in water. That is what is the acidity of a base. Then we went on to properties. I think 4 main properties of bases, alkalis we discussed. 4 properties, like for example, can absorb carbon dioxide. Then again whenever they react with ammonium salt, we will be able to produce carbon dioxide. In fact, sorry, it will be producing ammonia gas. Then third one was about the test. For example, from a soluble salt of heavy metals, it will be able to precipitate out colorful solutions, colorful precipitates in fact. So and after that, after finishing of base part, we discuss about pH. What is pH? What is indicator? Different common indicator. There are 2 kind of indicator. One is common indicator, the other one is the universal indicator. And for your understanding, I went to the lab, I prepared a video for you, and I think last week that video that you saw was a practical video about indicators. How 3 indicators, litmus, and I showed you both litmus paper as well as litmus solution. Then methyl orange and phenolphthalein, how actually they change the color in acidic medium and basic medium. Then I also gave you a very first hand video about indicator, universal indicator. I took some solutions and then put it on the universal indicator. You saw how the color was changing, and the color change was not same. So a universal indicator will give you pH value ranging from 0 to 14, but the pH paper which I used, the indicator, universal indicator which I had used, was giving you only from 1 to 11. So it was it had some limitation, but usually when we measure universal indicator, it gives you color from 0 to 14. So this is what we have already done today, and I'm discussing this all, I'm doing it as a recap because today we have nothing to do. In today's video, since I will be completing the chapter, and we have very little discussions only, because as I said, most major part of the chapter is already over. I thought now this class, that is your salt part, I have to do it in 2 classes, which is a little lengthy, but fortunately right on time only. I think we reach here, and then the board announced yesterday about the reduction in syllabus. Yeah, unfortunately, you know, in chemistry, in maths, 1 chapter I have already done, which they have already removed from the syllabus, and that is your shares and dividend. So I'll come to that on Monday, but or else all other chapters which I have done in maths, they are included in the syllabus, so you don't need to worry, except only for that shares and dividend, which is no longer there in your syllabus. I think in my Monday's class, in maths class, I'll be discussing about that. Alright, then here you are then salt. So we will discuss about, this is a part of acid, base and salt chapter, so we will be discussing about salt. Now since this salt definition can be very easily defined in terms of your neutralization, we discuss in the property of acid and base that acid will react with base to give you salt and water. So yeah, we are going to define this now. So we have already finished with acid, we have finished with base, but don't forget that salt is the production of the reaction between acid and base. This is what we call as neutralization reaction. So then how is this salt defined? Now see, I am going to define salt. Salt is a compound which is formed by the neutralization of an acid and a base. So that means by the neutralization reaction of an acid and a base, a new compound is formed, and that is what is salt. That is what is your definition of your salt, but that I'll call it as not the proper definition of salt. Then what is the proper definition of a salt? I think for that I'll just show you one reaction. This is sulfuric acid, I'm actually picking up that only, neutralization reaction, and here you are, I'm taking a base. So acid is reacting with base. Now see, first let me explain to this reaction, then after that I'll come to the definition, real definition of salt. You know, whenever a salt is formed, this metal of a base or a metallic radical, it can be ammonium also, by the way, it can be ammonium hydroxide, so it's not necessarily only metal, because sometimes it can be ammonium also. When the metal ion, that is of a base, is replacing this hydrogen, now see, how is this hydrogen replaced? Hydrogen may be replaced partially, so partially means I am making a small arrow, or it may replace it fully. So when the hydrogen of an acid, if it is replaced by a metal or an ammonium ion, partially or wholly, then salt is formed. That is what is the definition of salt. Okay, now see, let me replace it partially. So how many hydrogen do you see? 2. Now out of 2 hydrogen, let me replace only 1. That is why I use the word partially. So partially means only half of hydrogen is what I am going to replace. So here it is, sodium is going to replace that hydrogen, so it will form Na, but since I replace it partially, out of 2 hydrogen, only 1 hydrogen is left. Here it is, sodium bisulfate. So that means 1 hydrogen has been replaced with sodium. Another hydrogen is still there, you can see, and then plus this OH, your part, and your SO4 part which is there, is what is in fact going to give you. In fact, NaSO4 is what gave you NaHSO4, that is salt, and the other part is 1 hydrogen, and OH part is what is going to give you water. So this is what we can call it as partial replacement, partial, little bit replacement. But I said in the definition that it can also be replaced fully. Okay, now same reaction I am going to write, same compound I have taken, but now here the hydrogen is replaced totally, fully, both hydrogen will be replaced. Now when you are replacing both the hydrogen, then you will form sodium sulfate. Here it is, this sodium is going and replacing both, and since sulfate has a valency of 2, so I have to write Na2SO4 and then plus water. So that means this is also a salt, this is also a salt. So here, then as we are defining salt, what is a salt? Now I'll define again for the last time what is salt. Salt is that compound which is formed, this compound which is formed by partial or full, total, by a partial replacement or a full replacement, total replacement of hydrogen ion from the acid. By who is replacing? By the metal or ammonium ion. So that means when a metal or ammonium ion is replacing this hydrogen either partially or fully, then the compound which we call as salt is what is formed. This is what is the definition of salt. Or if you want to go for another definition, that I will call it as ionic definition of salt. Now for ionic definition of salt, then we have to say it in terms of ion. How did we say acid? Acids are those compounds which when dissolved in water produces hydrogen ion as the only ions or only cation. Only one cation should be there and it should be. And similarly in alkalis we discuss about produce OH ion as the only anion. So hydroxyl ion as the only ion. So for acid it was hydrogen ion or hydrogen ion, and for bases or alkalis it was hydroxyl ion. Then when you define a salt, then we can say that salts are those compounds which when dissolved in water produces cation other than hydrogen ion. So that means all cation but hydrogen ion should not be there, because if hydrogen ion is there then it becomes an acid. So then again the ionic definition of salt is that salts are those compounds which when dissolved in water produces ions, that is cations other than hydrogen ion or hydronium ion, and anion other than hydroxyl ion, because again if the anion is hydroxyl ion then it becomes a base. But then you have to say that salts are compound which produces anion other than hydroxyl. So that means except hydroxyl, any ion that you can think of. Similarly other than hydrogen cation or hydronium cation, you can think of any other cation, but hydronium should not be there or hydrogen ion should not be there. So that's why again for the last time if I define what is your salt, ionic definition of salt, then you say that salts are those compounds which when dissolved in water produces cation other than hydrogen ion and anion other than hydroxyl ion. This is ionic definition, and the definition which I told you, that was a very easy definition. What is a salt? Salts are compounds which are formed by the neutralization of acid and base. But don't say that, that is not a proper definition. And what I said just now about that is what is the proper definition of salt. Salts are those compounds which are formed by partial or complete replacement of hydrogen from the acid by the metal or ammonium ion. So then you can see from the acid here partially hydrogen replaced, still one hydrogen is there, complete replacement. Now based on what we have learned just now, our next topic which is now it retained in the syllabus is about kinds of salts. Now altogether there are 6 kinds of salt, but your syllabus is mentioning only 3 kinds which you have to do. Now what are the 6 kinds of salt? Just for your information I am saying they are called normal salt, acid salt, basic salt, then mixed salt, then complex salt and double salt. 6 of them, but the last 3 which I said they are no longer in your syllabus, so you have to only discuss 3. Now let me tell you now the first kind, normal salt. Okay, now I think it will be easy for you to understand what is a normal salt if you have understood this. Normal salts are those salts which are formed by complete replacement of hydrogen. See here, there was a complete replacement of hydrogen here. That means this salt which is formed is what is called normal salt. There is no trace of hydrogen. See, there was hydrogen but there is no trace of hydrogen here. So that means from any acid, when there is a complete whatever number of hydrogen are there, if all of them are totally replaced, then the salt which is formed is what is called normal salt. So here it is. So for example, if I am talking about an acid like HCl which has only one hydrogen, there is no chance for this acid to form a salt other than normal salt. They will always form a normal salt because only one hydrogen is there and that hydrogen will be replaced. Then plus base, if I am taking KOH. So yeah, acid and a base. So there is only one hydrogen, there is no question of partial replacement. It has to be completely replaced, only one hydrogen is there. So as this K is replacing, it will give you KCl plus water. So you can see there is no hydrogen here. So this kind of salt is what is your normal salt. Now let me show you the same reaction. Okay, here same reaction I can show you, this plus this. But 2 hydrogen were there or 3 hydrogen are there, like in case of phosphoric acid there will be 3 hydrogen. When all hydrogen are replaced by this metal, then there is no trace of hydrogen. Then we can say such salts are normal salt. Then going on to the second kind of salt, which is here, let's call it as acid salt. Here you are. What is an acid salt? Acid salts are those salts which are formed by partial replacement of hydrogen ion. partial, yeah, partial replacement. Two hydrogen were there, so out of 2 hydrogen only 1 hydrogen is replaced. Out of 3 hydrogen maybe only 1 hydrogen will replace, or maybe 2 hydrogen will be replaced, but there will be still some hydrogen still left in the salt. Such kind of salt is what is called acid salt. So that means acid salt formation is possible only and only for an acid which has a basicity which is more than 1, basicity 2 hydrogen, or maybe basicity 3. It is not possible for a acid whose basicity is 1 or which is monobasic. So every time it must be 2 or a 3 or a 4. So that is should be more than 1, because if only 1 is there here, that only 1 will be replaced. So there can be no partial replacement. There will be only complete replacement. That is why when 2 are there or 3 are there, then maybe 1 will be replaced, or maybe 2 will be replaced, but 1 will be still retained like this. 1 hydrogen will be still retained. Such kind. Now here let's see one example. Now I think I cannot give you nitric acid, because nitric acid also has only 1 hydrogen, so that will be replacement, it becomes a normal salt. I cannot say HCl because that also has only 1 hydrogen, but yes, I can give sulfuric acid, I can give carbonic acid where hydrogen number is 2, or I may give phosphoric acid where hydrogen number is 3. So yeah, then if I am talking about sulfuric acid, now you can see 2 hydrogen, and if I am reacting this with a base, okay, let me take the same reaction here, or maybe I can take KOH here. So acid and base. Now this hydrogen 2, if only one of them is replaced, the other one is still retained. Potassium will go and take the place of 1 hydrogen. So it will be KHSO4 and then plus water. So there, out of 2 hydrogen, only 1 hydrogen has been replaced. So the other one is still retained. Such kind of salt is what is acid salt. Yeah, I should tell you that it is a salt, okay, acid salt. Now you may say, sir, if you are saying acid also salt also, then what it is? Is it acid or is it a salt? Then I should say that is a salt, it is a kind of salt. It is a salt. But don't forget, acid salts when dissolved in water produces hydronium ion as one of the ion. It also produces hydrogen ion, it produces potassium ion, it produces hydronium ion. So since it produces hydronium ion, it also shows the property of an acid. That means if you are testing with litmus, blue litmus will turn red. So that is what is acid salt. Same way now, if I am talking about the third kind of salt, that is called basic salt. Now acid salt shows the properties of an acid. So same way a basic salt also will show the property of base. Again, basic salt will have the OH ion of a base will be partially replaced. Partially. That means it is possible only when the base is either your diacidic base or maybe a tri. So that means OH number should be more than 1 because it has to be replaced partially. Okay, since space is not there, so let me rub this. Okay, here it is, your lead hydroxide, and plus if I am taking, this is a base and an acid, so acid and a base. Now when an acid reacts with the base and 2,2-OH are there, and if that 2,2-OH out of 2, if only one of them is replaced with, see OH will be replaced with the radical now. Yeah, see acid will react with base to give you salt. Now the salt will be Pb. Now out of 2 only one will be replaced, the other one will be still there, and here you have Cl. This Cl is going and replacing it. Previously we discussed about incomplete replacement, partial replacement of hydrogen ion, but here it is partial replacement of hydroxyl ion. So out of 2 only one is replaced, and who is replacing? Not the metal, so it is the anion which is replacing it. You can see one of the OH ion has been replaced to give you a salt, and then the other one is what is water. Such salt is what is basic salt. Now why basic salt you can understand, because OH is there, so OH is the property of a base, alkalis, that is why it is called. Now how do you say this salt? Now don't say lead hydroxide chloride, we don't say it like this. Because of OH, the name of this compound, the name of this salt is called basic lead chloride. So because of the OH in the middle, we have to say basic. Don't say again, I am repeating, we don't say hydroxide here. There is no need of saying hydroxide. Simply because of OH, it is basic in nature, and that's why we say basic lead chloride. So same way, there are so many others where more than OHs are there. So if when incomplete replacement of OH is taking place, such kind of salt is what is called basic salt. Like acid salt showing the property of acid, same way basic salt will show the property of base. Why? Because when you dissolve this in water, so they will break, they will in fact dissociate and ionize to give hydroxyl ion as one of the ions. Since one of the ion produced will be hydroxyl ion, and since hydroxyl ion has a property characteristic property of a base or alkali is hydroxyl ion. Since one of the ion produced will be hydroxyl ion, that is why it shows the property of a base. And finally, something which we have already discussed about, what is the action of acid on carbonate, sulfides, sulfide. This 3 is what is mentioned there in the end of your syllabus. If you see the revised syllabus, then we have already discussed that. So in the properties of acid, if you remember properties of dilute acid, I have already said that every acid will react with a carbonate, metallic carbonate and metallic bicarbonate. A metallic carbonate, here it is metallic carbonate or a metallic bicarbonate, it may be bicarbonate. So to give you what? So here it will give you, any acid will react with the carbon bicarbonate to give you one gas, and that is carbon dioxide. So it will give you one salt and it will give you water and carbon dioxide. So I am discussing this twice already. In acid section also we discussed in the properties of acid. If you see that video again, you will see I have discussed already that. So then second one is if acid is reacted with a metallic sulfide or a metallic bisulfide. So if it is carbonate, carbon dioxide. If it is sulfide, it will give you a salt, then it will give you water and it will give you sulfur dioxide. So if you remember, carbon dioxide is tested with lime water, milky. Sulfur dioxide, if you remember, potassium dichromate solution is turned green. So if you remember, then third one is, and dilute acid, when it reacts with metallic sulfide, okay, this is sulfide S, then it will give you a salt and it will give you that rotten egg smelling gas, hydrogen sulfide gas. And this gas, if you remember, I said we test it with lead acetate paper. Lead acetate paper is turned shiny black. So this completes your chapter, acid, base and salt, which was a lengthy chapter, but then luckily I think it has been reduced. Now when you do your questions, now I want you to do all those Icse examination questions which are there at the end of your book. But please note that you don't have to do any question based on preparation of salt. Yes, for salt section, if any question in the salt section, you have to only do definition of salt, kinds of salt. There are also just 3 kinds. In the older syllabus, you know, all 6 kinds were there in the syllabus, all 6 kinds of salt, but now you only need to do this. So avoid those questions where salt preparations are there. And in fact, in your board exam ICSE questions, most of the questions were asked based on preparation of salt. But thankfully now that part is gone, so that's why even when you are doing those previous ICSE questions, examination questions, you will find that most of the questions you have to avoid it because they are no longer in the syllabus. So I want you to do those exercises, and if problems are there, let me know. So today I'll stop. Today's video is a very short one. If there is a doubt, let me know. So till the next class, goodbye.